Good afternoon, everyone. I know I am in between you and lunch, so I will try to cover it as fast as possible. But this is again a very important topic. So, in our today's session, I am going to basically cover that how the engineering information can be leveraged by owner-operators for the project as well as during operation and maintenance. So in our today's session, main agenda will be what are the challenges generally owner-operator face, then the vision for the owner-operator for the digitization, and then what is the as-is situation and what can be the solution for that, and then some references. So if I broadly categorize these challenges into two, project and operation. So when we are coming up with new project, what are the key challenges normally owner operators are facing? So most important challenge is poor visibility of the project progress. Normally what happens, we are getting these reports, weekly, monthly report in form of PDF or Word or in Excel, and we have to believe that report, and we cannot drill down, we cannot visualize in 3D. So this is a major challenge. Second, if there is any impact, like there is a delay in my equipment delivery or there is a change in the schedule, I am not able to visualize that, how it will impact my complete project, what are the cascading impact. If a particular equipment is getting delayed, then how it will impact my overall project schedule. Another important thing is rework on the engineering changes. What happens, we are using the engineering applications in silos. So if there is a small change in the process, in the temperature of a particular pipe, it will have a lot of cascading impact. Like it will have the change in the insulation, it will probably have an impact on the clash, it will also have an impact on my bill of material, it will have an impact on my construction. So if I can handle these changes efficiently, then it will help me to manage my complete project design as well as construction efficiently. And last and most important things, we have today seen a lot of things about the data. So data governance. For any plant, data will start getting built up during the project phase. So it is very important to have the right data in place when we get the handover from the EPCs or the PMCs. So data governance is very important, and today we are getting this data in form of hard disk or in form of hard copies, and it becomes very difficult to ensure that all data are complete and compliant. When we get this handover and when we start operating the plant, we are facing another type of challenge. That is like when we start the operation, first thing is we have to keep our operation and maintenance systems up. And for that we need to feed a lot of information what we are getting from the EPCs or PMCs, like assets, their names, attributes, so that we can do the maintenance and operation efficiently. Traditionally this used to happen through Excel or through manual entry, and this also takes a lot of time and effort. Another important thing is missing data or documents in handover. So as I mentioned, we are getting this data in in trucks or in hard copies, and it is like quite impossible to ensure that all the data are complete, and when we get into the maintenance or we are getting into any shutdown activity, we realize that some PNIDs are not latest or some operational parameter or design parameters are missing, and we need to depend on the EPCs or the OEMs to get this information. Last, delay in accessing the informations. We are using different digital informations, but applications, but those are in silos. Let us say if I have to generate a work order, then what are the major challenges which we are facing as an owner operator during project as well as operation phase. So we'll see how we can solve these challenges in this session. So what should be the solution? What should be the vision for the owner operator? So owner operator should have a web portal which is kind of your search engine of your plant, where for any specific asset or a tag, you should able to access all the information which is coming from different silos. It can be 3D model, it can be engineering document, it can be predictive information, it can be OEM document. So all these various information or data silos which are coming from different sources should able to access through a portal without having any high-end application installed quickly in context of a tag. So if we have this kind of solution, this empowers our workforce and this helps them to take the decision quickly. So if I broadly categorize this into two categories. First is the existing plant, where our plant, we have seen that some plants are like very old, 15, 20 years old plant. And second is the ongoing project or upcoming plant. We have also seen that a lot of expansion are happening. So how we can handle this for the upcoming plant? So first I will address the existing plant. What can be the solution? So now let us see, this is my existing plant. This is as is situation. Probably it can be better, but this is how our existing plant looks like. And then we have the information, all the engineering information in such format, like it can be in AutoCAD, it can be in PDF, it can be in hard copy, and all the various comments are being made on that to capture the various changes which are happening during MOCs. Now what should be our goal? Our goal should be, from our present as is situation, how we can move or how we can transition to this digital twin or the digital twin of my existing plant. So for that, this is the solution, where first you should have the collection of all the existing engineering document, and then we need to capture this existing plant information by the laser scan. Once we have these documents and the as is condition captured, we can bring this information in authoring engineering application, where we are creating the intelligent 3D model, intelligent PNID, which is integrated. And then once we have this intelligent 3D model, PNID, all the engineering information, we can push this information in my digital twin, where I can access all the information without the need of authoring application. I can even scale it up by integrating additional operational data sources. So if I have to achieve this milestone, what I can do, I have to take the different steps. So my first step will be gathering the information, second step is creating the intelligent model, and third step is building the digital twin. So now first step, how we can gather the information. For that, first we need to do the laser scan. To do the laser scan, we need to identify the different location from where I am going to do the laser scanning, so that I can capture all the area of my plant. Once I do the laser scan, what I will get? I will get the point cloud data, and I will also get the panoramic bubble view, panoramic image of my plant. Now this information basically gives me the as is condition of the plant. Now next step is, with these engineering documents and the as is condition, we can take this laser data into the ,3D modeling application. Now here you can see that all the point cloud data which are coming from my laser scanner, I can visualize them. I can see the different scanning location from where those scans were done. I can go to a specific scan and I can see the panoramic image of my plant. So basically I don't have to go on site, I can directly see my as is condition sitting in the office. And this is very useful when we are doing even expansion. So sometimes when we are scaling up, we are doing the expansion, we are involving the EPC, and EPC doesn't have the information about my existing condition of the plant. And we have to ensure that I am doing the expansion, I am adding the additional equipment which are clash free, which has a sufficient maintenance space. So all this activity I can do once I have this laser data inside the 3D environment. Then what I can do further, I can go and I can create the 3D model. Now either I can create the complete 3D model of my as-built plant, or I can create the partial 3D model for which I am going to do the expansion. So here you can see that I can see some intelligent 3D model, and I can also see the laser data of my existing site condition. Now when I do the expansion, sometimes we are replacing the major equipment also. So here what we can do in AVEVA E3D design application, I can bring laser data, I can visualize it, I can create the additional 3D model, I can see it in a combined view. Not only that, if I am going to replace any equipment, I can select small area of the laser data. Let us say if it is a pump, I am replacing this pump, I can select area, I can create a boundary around the pump, and then I can demolish that laser scan, so that from that area laser scan will be removed, and I can place a new equipment in that place, I can route the necessary pipe, and I can make the connection. So these are the various ways I can leverage my as-is condition of the plant, and I can use it for the expansion. Here we also have discussed about the safety. So it has a lot of benefit because the person doesn't have to go on site. He is not exposing himself to the operation, means plant which is in operation. So everything can be done with high accuracy sitting in the office. And the accuracy of the laser scan data can be plus or minus 1 mm. So practically if these things are being done manually, then there is always a chance that my measurements are not accurate. When I generate the drawings, it ends up in clashing on site, it ends up in the rework. But with this, I am ensuring that my BOM is accurate, all the drawings are accurate, which are not ending up any rework in the construction. Further, I can use this laser data while creating the drawing. So I am creating the intelligent model for which I want to do the expansion. I am also embedding it with the laser data so that I can do the measurement with my as-is condition of the site and the new equipment which are coming as a part of expansion. So even I can generate the drawings with the laser data. Now PNID. Normally we have the PNID in AutoCAD or PDF. So here with AVEVA PNID we can create intelligent PNID. This PNID helps us to create or extract the bill of material to validate the PNID. If somebody is, let us say, connecting the 100 NB pipe with the equipment's nozzle of 150 NB, then system will throw error that there is a connection error. But such kind of things we cannot check when we are using my AutoCAD or PDF PNID. Now another important advantage of intelligent PNID and intelligent 3D model is integrating PNID and 3D model. Normally what we do, we update PNID and then I do the manual checking of my 3D model that my PNID, my 3D model is as per the PNID. But with this intelligent PNID, I can ensure that my 3D model is as per the PNID, all the tagging, all the specification, piping specification, valve specification are as per the PNID, and we can avoid the manual checking. We can avoid any rework which happens if we miss such kind of points while manual checking. So what you are seeing is I am updating my 3D model based on the PNID, and there is a difference in name of the valve tag which is there in the PNID but not there in the 3D model. So I am updating my 3D model based on the PNID. Yeah. So similarly, it's not limited to PNID and 3D model. We can also create the intelligent solution for the electrical and instrumentation, where we are creating SLDs, hookup drawings, termination drawings intelligently, and everything is integrated. So as initially I mentioned, that if there is any change in the temperature which is coming from the process side, I can ensure that whatever cascading impacts are happening either in the 3D model or in the PNID or in electrical instrumentation or any of the deliverable like line list, equipment list, everything is integrated, and I ensure that whatever deliverables or bill of material are getting generated that are accurate, and we can avoid the wrong material ordering or the rework at site. So this is about step 2, where we are creating the intelligent 3D model and intelligent other engineering deliverables. Now once we have that, we can get into step 3, where we are creating the digital replica of my physical plant. Here, if I categorize my all the different data into broadly 5 categories, then first is a structured data. Now the structured data are like data which are in the tabular format, and various applications are built on top of this data. Second is unstructured data, where data is residing in form of file like PDF, Word, PowerPoint. Third is our engineering deliverables, which are either in AutoCAD or DGN. Then the 3D model, what we have seen. And last is the laser data. So these, all the different types of data we can bring inside the single platform through our gateway. So we have the connectors, and we are kind of application agnostic. So any kind of applications can be used. Our connector can extract the data. It can validate those data against the standard. Definitely each plant will have their unique naming philosophy for tag and document. So it can validate against them, and then it pushes the information into the engineering data warehouse, where we have the information about tag to tag, tag to document, all the network of information are residing in my engineering warehouse. And as we have seen earlier, all this information can be accessed through browser. So we don't need any authoring application. Whatever we are seeing the different types of data, we can bring all the different types of information in context of a tag, and we can visualize them on the browser. We don't need any authoring application. And further, we can add additional data source which are coming from the operation side also. So various operation and maintenance application can be integrated. We can integrate the operational data, and then it becomes my true digital twin, which is a digital replica of my physical asset. So this is about how I can use it for my existing asset. Now let us understand it with a practical use case. Let us say on site there is an alert coming on a pump, and we have to, our maintenance team has to generate a right deliverables. They have to provide it so that rectification can be done on site. Practically we know that this takes a lot of time to access various information which are residing in different silos. But when we have this digital twin in place, how efficiently we can access the information and we can start the action.
The maintenance team receives an email from PiVision notifying them of an anomaly. The maintenance planner opens up the email to understand more about the notification generated. The email indicates that pump J9002B's efficiency is running low and has fallen below the hourly average efficiency of 71.87%. The notification email has the exact date and time data on the occurrence of the event and also show the current conditions of pump J9002B. A pump overview hyperlink is also available in the email, which allows the user to navigate directly to PiVision. Once in PiVision, the maintenance planner can view the pump's basic data, such as its properties and maintenance information. Below we have graphs plotting real-time sensor data coming in from the field. A sharp decrease in pump efficiency is clearly visible on the graph. Drilling down on the pump efficiency graph allows for further investigation into the efficiency loss of the pump. Switching between different time frames allows the maintenance team to view historical trends and observe changes in temperature and other operational data noticed during the same time intervals as that of the sharp decrease in pump efficiency. Plot lines differentiated by different colors represent rated and hourly average data. Clicking any point on the graph gives the maintenance team the exact date and time information of when the loss inefficiency occurred. While the maintenance managers and planners have all the relevant operational data associated to this pump available on this screen, they need further master data and document information to find out the root cause for the constant drops in pump efficiency. To get to the bottom of this, the maintenance planner navigates to AVEVA's Asset Information Management solution that brings up the tag summary page for the pump. Here the maintenance teams can view all the metadata of the pump along with just the right operational and commissioning data. Over at the Documents section, the maintenance and operations teams can view active or past work orders. Opening up Work Order 93453 shows vital information on the history of the pump. Now that we know the motor has been experiencing overheating issues in the past, let's take a look at any incidents that have taken place during previous maintenance tasks and activities. The incident report shows that there has been seal failure in the past, resulting in liquid spillage. All the required information about that past job and its resultant activities are available for the maintenance team to review and prevent future incidents. The Parts and Components sections shows all the parts that comprise within the pump casing, and can also indicate replacement parts or any special equipment needed for maintenance work. With all this information, it is clear to the planner that an inspection is needed on the pump. The maintenance planner opens up the risk assessment report to view all potential hazards of the job. The hazards and risks associated with maintenance activities for the asset along with existing controls in place to mitigate these risks are all available in this document. The maintenance planner now navigates back to the tag summary page to access the P&ID diagram of the plant. The P&ID shows the process flow surrounding the pump J9002B and depicts vital information of other surrounding assets and valves that have a direct effect on the maintenance plans of the pump. Markup information on the top right shows that maintenance engineer Jim has an upcoming maintenance activity planned on assets near the pump. The maintenance planner uses the markup functionality to give maintenance engineers and technicians a heads up about previous incidents that have transpired in the area and directs them to Incident Report INC 002. AVEVA Asset Information Management allows the maintenance teams to view and access the plant's 3D model. This helps the maintenance planner visualize the area and plan and create work packages better. The maintenance planner can plot points within the 3D model to calculate distances and measurements of the site to ensure technicians have the right space to execute their work orders. While the maintenance teams are busy planning and creating work packages in AIM, they can also view real-time pump data, and can fairly quickly access operational data and bring up the pump efficiency graph from PiVision as an external view, thus bringing together operational and engineering data, all in a single screen to make real-time data-driven decisions that in turn equip maintenance technicians and engineers with accurate information to help them do their jobs more efficiently. Now that the planner has reviewed all the data, it's time to package it all up and send it out to the team in the field. The maintenance planner simply adds all the documents to their basket and reviews it one last time before exporting it into a work package.
Yeah. So practically, if this activity has to be carried out in our present scenario, we take a lot of time to gather the information, to identify the right document which are specific to that particular pump. Now with this digital replica of the physical asset, we can get all the information in context of that particular tag within a very short time. And this saves a lot of time or unproductive time, I would say, of the plant person. Now, this was about the first category. Second category is about the upcoming plant, or which are the ongoing project. Now in that, it is very important, and nowadays there is a tradition that this digital handover is being asked at contract phase itself. So when you are placing the contract on the EPC or PMC, you should ensure that you are asking for the digital handover with all the native database, so that you don't have to do the laser scanning and you don't have to build the digital asset, because all the EPCs are using the tool to create this digital part or digital 3D model. So that can be leveraged by owner operator by asking them in the contract phase itself. So in that scenario, normally what happens that all the EPCs are using this engineering tool in an integrated way. So that helps as an owner operator to ensure that your projects are getting executed efficiently. EPCs are managing the changes in the engineering efficiently, and ultimately money saved by EPC is ultimately getting translated to owner operator only. So these are all the different authoring applications which can be leveraged in an integrated way. The solution is unified engineering. It starts from the process simulation and engineering, electrical, instrumentation, PNID and 3D modeling. So this covers the complete design phase of the project. Starting from my concept design where I do the steady state and dynamic simulation. Then I get into the feed stage where I generate the PFDs. Then I get into the detailed design and which gives the input for my procurement and construction. Now further, when I am using this intelligent engineering tool in the project phase, I can use this digital twin for the project progress monitoring. So as I mentioned, this is a agnostic tool, application agnostic tool. So it can take the data from the engineering application, it can take the data from the project execution application, like material management or Primavera for project planning or construction management. All the informations can be pushed into the digital twin solution. In the project phase, we can call it as a project monitoring and data governance platform. So here you can slice and dice the data, you can build various KPIs and you can monitor the project progress through the dashboard. So here once you have all the data inside the platform, you can, in the project phase, you can slice and dice and you can build various dashboards which gives you insight of your project progress. And here you can further drill it down to really check that informations are correct or not. Not only that, we can superimpose my progress on 3D model and I can visualize it. Let us say this is my procurement status. So I can visualize my key critical equipment's procurement status on 3D model, and this gives me a lot of insight and helps me to identify that what can be the cascading impact if my particular equipment's PO is not placed or is not delivered. So these kind of insights we can easily get once we have this information in 3D. Similarly, I can see the construction status. What you are seeing is a pipe fabrication status, which is overlapped on 3D model, and you can see that how many pipe spools are fabricated, erected, welded, painted. So these kind of insights helps a lot to owner operator to get a confidence that my project is progressing well, it is on time. Further, I was also mentioning about the data governance. That is also a very big challenge. So what happens normally when you get the data as an owner operator, you are not able to ensure that all the data are compliant, consistent and validated. But once we have all the data coming inside this digital twin platform, what we can do, we can ensure that, let us say particular design temperature of a tag is coming from my equipment list and coming from my data sheet. If those informations are not same, then we can extract it as a report and which tells me that these informations are not same. You can, in the project phase itself, you can ask your EPC to correct and give you the updated data. If they have given you a lot of documents and let us say for a particular tag, that tag is not present in 3D but tag is present in PNID. You can extract this report and you can say that please update the 3D model for this tag and do the handover. If my critical attribute which are important from operation perspective, which are not there in the data sheet, you can extract a report and you can give it to your EPC that please correct and give it to me. Normally such kind of things at the project phase as an owner operator, you cannot check, because there are lots of documents which practically difficult to identify such gaps. But with this tool, you can get this information with click of a button. Now, once you have this digital handover from your EPC, you can leverage this digital twin to push the information in your operation and maintenance application. So here you can extract the information in various formats. You can slice the information, like your maintenance management system will need a certain type of information. Your work will need some certain type of information. So you can slice the information, and which are validated, trusted, you can extract it and you can push it directly in your operation and management application. And again, you can add those operational system back into this platform, and this becomes your digital twin, which you can leverage it throughout the 20-25 years of life cycle of the plant. So initially I discussed about the challenges, and with this single platform you can leverage it throughout the life cycle of the plant, being at a project phase, handover, or operation and maintenance. And this solution is proven even in the industry also. Evonik, they have sites in more than 100 countries. They have the assets of around 1 billion pound of asset which they are managing across this different site, and they have leveraged this complete solution what just I have shown. They are using unified engineering, they are using asset information management, and they are using point cloud manager. So this tool helps them even during operation and maintenance access all the information less than a minute, and this empower their workforce to take the decision quickly, and which is with the information which is validated. So yeah, this was the message, and I also suggest that we have a booth on this. If you have any question, there are many other references we can discuss at the booth if you have any more question on this topic. And we will also have another session which is again on the same topic for the customer, from the customer side, who is using this tool for the digitization, for creating the digital twin of their plant. Thank you.